So let's see the part 2 of electronic devices. Right. So study we have completed up to question number 6. So today is based on question number 7. So it is your part 2 of electronic device. Right. So let's see the question number 7. For transistor action, which of the following statement is correct? So it is talking about for transistor action. Which of the statement is correct? So your transistor is looking like this. So this is the diagram of transistor. So there are three terminals: emitter, base, collector. Right. So these are the three terminals. For transition actor, emitter base junction is always forward bias, right? So this emitter base junction, this part, should be the forward biased. This should be forward biased, right? And collector base junction is always reverse bias. Collector base, this is your collector base junction. Collector base junction should be reverse bias. For this base has to be very thin and lightly doped. So this is base connected, right? Which should be thin and lightly doped. Lightly doped. So this is the point you should remember the fourth transistor to be in the action. Now see the question number 8. 8 is the increase in the width of the depletion region in a PN junction diode is due to. So there is increase in the width of depletion region in a PN junction. In a PN junction diode is due to increase in reverse bias. Due to increase in reverse bias. Reverse bias. When it is reverse bias, then its depletion region increases. So this is the 8th question. Now see the next one. 9th. So for the logic circuit given to it, so this is your diagram given to you. This is the NAND gate taken output Y. This is the diode. This is A bar. This is diode 2 B bar. This is your A. This is your B. So what will be the output? Y is called as output. So Y is equal to A bar plus B bar. Right. So these are the two inputs for this AND gate, right? This is the input. This is called NAND gate. Right. AND gate will be looking like this only. Right. Here dot is there, then it represents AND gate. Okay. Now take the bar also. So it is double bar. Then it is converted into A bar dot B bar and whole bar. Then it is coming out to be A into B. A into B is your product of two input. Then it's it is coming out to be AND gate. So this is your AND gate, right? Now see the next question, that is 10th one. Next is 10th. Out of the following, which one is forward biased? So you have to tell the forward bias. So in forward bias, P terminal is connected to higher potential. So what is the condition for forward bias? In forward biased, P terminal is connected to higher potential, right? And in terminal is connected to lower potential. So it is asked in 2020. So for forward bias, P should be the higher potential, right? And that will be in the lower potential. So D option is matching, right? So your diagram is given like this. So zero value is more, right? So it is at higher potential. And this is at low potential, negative part is given. So this is at lower potential, right? Now see the next sum. De Broglie wavelength of electron moving with kinetic energy. So kinetic energy is given, that is 144 electron volt, right? So you have to find the de Broglie wavelength. So de Broglie wavelength is given by h upon under root of 2m, right? Where m is the mass of electron, that is equal to 9.1 into 10 raised to minus 31 kg. Right, now put the value, then you will get the lambda. And kinetic energy is also given, that is 144 electron volt. So convert into joule. So it is 144 into 1.6 into 10 raised to minus 19 joule. Kinetic energy. Right. So HMK in the directly wavelength. So which one the answer? So it is of after putting you will get a value. So lambda D you can find. H is the Planck constant, that is 6.636 10 raised to minus 34 divided by under root of 2m. M is 9.1 into 10 raised to minus 31. Kinetic energy is 144 into 1.6 into 10 raised to minus 19. So this will be the lambda D. So please write it down. Now see the next question. So after putting value, you are getting 102 into 10 raised to minus 3 nanometer. N for nanometer. Let's see the next sum. Question number 12. So question number 12, NPN transistor is connected in common emitter configuration in which collector voltage drop across resistor is given. Right, 800 watt connected to the collector circuit is 0.4 volt. So your diagram is given like this. This is RB. This is 800 watt. Current is IC flowing through the collector. This is the base current flowing through it, zero point 0.8 volt, right? So let's see. So IC current through collector is given by voltage drop across collector. Voltage drop across collector is divided by load resistance. So IC is equal to 0.8 divided by 800. Right. So voltage across collector is given, right? That is 0.8. So this is your VC. And load resistance is given, that is 800 ohm. Right. So this is basically your resistance, R value. So as we know, current is equal to voltage upon resistance. So we have put the value and get it. So it will be 1 milliampere. Right. It is asked in NEET 2020. Let's see the next sum. Question number 13. 13 is which of the following gate is universal gate? So with the help of NAND gate, other gates can be obtained. This is called universal gate. So which gate is called universal gate? AND gate. AND gate. Right. So with the help of it, other gates can be obtained. Right. Thus, it is called universal gate. Now see the next one. Question number 14. For intrinsic semiconductor is converted into N-type extrinsic semiconductor by doping it with. So for making the P-type, so N-type semiconductor is obtained when intrinsic semiconductor is doped with pentavalent impurities. So N-type semiconductor. N-type semiconductor is obtained when in intrinsic semiconductor is doped with pentavalent impurities. Right. So pentavalent is of group 15, right? So when it comes out to be like nitrogen, phosphorus, arsenic, antimony, bismuth. Right. So this is the atomic number 7. So it is 2,5. So pentavalent means its valency should be 5. So it will contain the 5 electron in its last orbit. Electron in its last orbit. That is called pentavalent. Right. And N-type semiconductor when silicon or germanium, when it is doped with like nitrogen, phosphorus, arsenic, antimony, or it is called group 15, then it forms N-type semiconductor. Right. And when it is asked like P-type, so when it is doped with group of 13, like boron, aluminum, gallium, indium, thallium, then it forms P-type semiconductor. right? This is called extrinsic semiconductor. And N type means intrinsic semiconductor. Now see the question number 15. A parallel plate capacitor having cross-sectional area A, separation D has an air between the plates. Now an inserting slab of same area but thickness D by 2 is inserted between the plate. Right, dielectric constant is 4. The ratio of the new capacitance, you have to find it. So there is a parallel plate connected to it. Dielectric constant K is given to it. Total distance is D. This is D by 2 given. So let's see. Original capacitance is given by C is equal to epsilon naught A by D. So new capacitance will be, this is the original capacitance. Next is new capacitance is equal to epsilon naught A by D. So it will become D minus D by 2 plus D by 2K. So it will become, after solving, 8A epsilon naught by 5D. So this is the new capacitance obtained. So if you want to take the ratio, then take, so it will be 8 by 5, right? So C by old by new. So it will be epsilon naught A by D divided by 8A epsilon naught by 5. So this will get cancelled with this, and this D and D get cancelled. So it is coming out 8 ratio 5. Now see the question number 16. A circuit Boolean operation represented by the circuit given. So there is diagram given to it. This is resistance R. This is LED Y. Right. This is resistance R plus 6 volt. And it is grounded. So let's see, from the given logic, LED will glow when the voltage across LED is high, right? So the truth table, it is out to be AND gate. So it is given 0, 0. So you can write the combination also. This is A, this is B, this is Y. So it is given signal. This is your A point, this is your B point, this is 0, this is 1, this is 0, this is 1. Right. So its combination will be like this: 0, 0, 0, 1, 1, 0, 1, 1. So find out the value Y. So when it is 0, 0, right? So it is high. From the given logic circuit, LED will glow when voltage LED is in high. Right. So 0, 0 means it is coming out to be 1. So it means Y is nothing but it is A into B bar. Right. 0, 0 means 0. and bar of that is 1. Now 0, 1 is 0 and take its bar is, then it is 1. 1, 0 is 0 and bar is 1. And 0, 0 means 1, 1 means 1 and bar is 0. So this is the output of AND gate only. Output of NAND gate only, right? Now see the next sum. Question number 17. A parallel plate capacitor of capacitance is given. C is equal to 20 microfarad. Is being charged by voltage source whose potential is changing at the rate. So potentially changing means dV by dt. It is given by 3 volt per second. The conduction current through the connecting wire and the displacement current of the plate capacitor will be. It is asked in 2019. So let's see. Capacitance of parallel plate is given by, that is 20 microfarad. So convert into standard, so it will be 20 into 10 raised to minus 6 farad. Right, so this will be the C value. Next is rate of change of voltage per second is given, right? So this is the rate of change of potential, rate of change of potential. So it is given, and as we know, charge is equal to capacitance into voltage. So difference this equation with respect to time. Differentiate with respect to time. So then it is become dq by dt is equal to C dV by dt, right? And as we know, IC is nothing but it is dq by dt. It is differentiation of charge with respect to time. So IC will be 20 into 10 raised to of minus 6, it is given, right? And so I put here C value. So this becomes your IC, right? This value. So after putting this value C, we have put 20 into 10 raised to of minus 6. Then dV by dt is nothing but it is 3V by second. So it is multiplied with 3 V by second, voltage by second. So multiply it, you will get 60 into 10 raised to of minus 6. So it is equal to 60 microampere, right? So then ID is equal to IC is equal to 60 microampere. So this is the value we have got. Now see the next sum. Look at the question number 18. 18 is asked in NEET 2019. So for P-type semiconductor, which of the statement is correct? So it is talking about P-type semiconductor. So let's see. So P-type semiconductor, intrinsic semiconductor is doped with trivalent impurities, right? In the previous question, I have explained it, right? Like silicon and germanium, it is doped with trivalent atom, trivalent atom. So it is your group of 13, like it start from boron, aluminum, gallium, indium, helium. So atomic number of boron is 5, so its electronic distribution is 2, 3. So its valence electron is 3. Valence electron is nothing but it is 3. And when silicon, it comes under the group of 14. So it contains, suppose atomic number is 14, silicon. So electronic distribution is 2, 8, 4. So its valency valence electron is 4, right? So when 4 docked with 3, it forms 7 electrons, right? So it requires more 1 electron. So one required electron is there, then it forms extrinsic semiconductor, extrinsic semiconductor, and it forms p-type semiconductor, right? So in trivalent impurities, that creates deficiency of the valence electron called holes, and here holes will be the majority charge carrier, majority charge carrier. So this is your charge carrier. Now let's see the question number 19. So in the circuit shown in the figure, input voltage is given as 20 volt, right? And voltage across base emitter is equal to 0, and voltage across collector emitter is equal to 0. The value of IB, IC, and beta you have to find it. So diagram given to you like this. This is RC, resistor through collector, that is given 4 kilo ohm, right? This is the emitter, this is your collector, this is your base, whose resistance is given to it. Resistance through base is given RB, that value is 500 kilo ohm, right? Input voltage is VI. So it is asked in NEET 2018. So how will you calculate the value? So let's see. From the transistor is NPN, right? So your transistor is NPN transistor, NPN. NPN is type of the transistor, right? So now see, so voltage across collector. So VCC is equal to IC into RC plus VCE, right? So this, we are talking about this voltage. So VCC is given by current through collector into resistance plus VC, voltage across collector and emitter. So now put the value. So how much it is coming out to be? VCC value is given. This voltage is VCC. So it is 20, right? And IC value we don't know, right? And RC value is how much? It is 4 kilo ohm. So it will be how much? It is 4 kilo ohm plus VCE value we know. That is how much? VC is given. How much it is? 0 given, right? So this value is 0. So put here 0. So you have to find. So this value is given. Voltage across collector emitter. So voltage across this collector emitter is 0 volt. So it is 0. So IC is nothing but it is 20 upon 4 kilo ohm. So it is coming out to be 20 by 4. Kilo means 10 raised to of 3. So divided by 5. So it is IC is nothing but 5 into 10 raised to of minus 3 ampere. So answer will be 5 milliampere. Now see the next sum or remaining part of this question. Next part is you have to find the IV value. So IB is given by input resistance, input voltage by resistance of base. So it is 20 volt given to it, and RV is 500 kilo, right, ohm. So its value is coming out to be 40 microampere. That is current through the base. Now see the question number 20. 20 is in a PN junction diode, change in temperature due to heating. So what happened to the heating? So as a result of heating, temperature increases, with which increases large number of electron hole pair, which lead to increase in the conductivity. Right. So as a result of heating, temperature increases, which generates large number of electron hole pairs, which leads to increase in conductivity. Right. So as a result, current is given by I is equal to I naught E minus QV by KT. Overall resistance diode change when effective forward and bias reverse. So this is the current formula given to it. Let's see the question number 21. In the combination of the following gates, the output can be written in the terms of input A and B. So it is given as like this. So circuit can be reduced to this point, and the gate whose input will be A and B. So this is also NOR gate, or means NOR, right? And its combination is given to NOR gate again. Then it is NOT gate. So this is your NOR. This is again NOR. Its output is Y1. Its output is Y2, and its is Y. This is your NOT. So Y1 is given by A plus B bar, and Y2 is given as Y1 plus Y2 bar. So after putting the value, you will get A plus B, right? So Y is coming out to be Y2 bar. So it is nothing but it is A plus B bar, which is NOR gate. So this is given by NOR gate, whose output is